Okay, so the recording is now in progress, and we'll continue our discussion what we started in our last class. We are in a new module, and we were talking about uh, wireless communication networks. And in wireless communication networks, in the first class, we talked about different terms like wireless, cellular, mobile, and so on. And we have explained the differences. Then we have talked about the basic structure of a cellular mobile network. What are the components and what are their names, how they're connected with each other. And the motto of the last class was to explain the basic concept that in a wireless network, not all links are wireless. I hope you remember that a communication network is made up of nodes and links. So in wireless communication network also we have nodes and links. The nodes probably you know quite well because they are cell phones, pagers, and so on. Then there are some nodes like the towers which you can also see, but there are other nodes like mobile switching centers which probably is beyond the visibility of the public eye. Now, the major idea was that although the link between the mobile phones and the nearest tower is wireless, but from the tower onwards, all the links are mostly wired. So the last class was dedicated to give you a basic concept that wireless networks do not have or does not yes, wireless networks do not have all the links as wireless. Rather, they are mostly wired, and only the user end part is wireless. So it's something like an wireless networks are always an extension of a wired network. So you have to keep that in mind. Like wireless networks are not always all wireless. So I will just go through quickly the slides which we presented in the last class, and then we'll continue with today's class. So in the last class, I will share my screen. Okay, I guess now you can see the screen of my computer. I have not made it full screen because the size of the text is quite large. And I can switch between the two views very easily if I don't go for a full screen thing. Okay, so the tech terms that we described in our last class was what is wireless, what is mobile, and what is cellular. And we have described that wireless is the big umbrella where every technology falls under, and wireless is a technology where there is no cable between a transmitter and a receiver. That's what wireless is. So whatever you think fax or communication between two towers or satellite and dish TV or cell phone and tower, anything, everything and anything that has no cable between transmitter and receiver comes under this big blue oval which is called wireless. Now, mobile is a subset of wireless where at least one end of the link is movable, like either the transmitter or the receiver, or both are movable. So, the fixed wireless, there are some fixed wireless, and there are mostly mobile wireless kind of things. Now, mobile wireless can be a cordless phone or it can be a walkie talkie and so on. But all these technologies are not necessarily cellular. So, what is cellular? Well, cellular is a technology which is mobile and wireless, but it is based on cells. What is cells? Well, when we consider the area that is covered by a network, which is divided into small regions, they are called cells. And we intentionally make such cells so that the transmission in one cell does not interfere into other cells, and thereby we can increase the capacity of the network. So this is what we described in the last class, and then we talked about the evolution. We said how the wireless networks evolved. Like there was a demand from the public safety departments, for example, police and fire safety, and then there were some people demanding that their cars should be having some phones, and then many technologies evolved like cordless and wireless and local loop and pager and cellular, and then WLAN as well. And this is where we ended our last class, which is the elements of a cellular communication system. We said that there are three basic elements. One is MS or mobile station. Mobile stations are mobile phones or other gadgets which you use in a wireless manner. It can be a laptop with a wireless dongle as well. The BS stands for base station. Base station is a tower which is in every cell, which you probably can see fitted with some white kind of rectangular antennas. And then there is something called MSC, or mobile switching center. In mobile switching center, it's like an telephone exchange kind of thing, which is connecting all the towers with each other. So the connection between MS and BS is mostly wireless, whereas the connection between MS and BS is always wireless, whereas the connection between BS and MSC is mostly wired. In some cases, that link can be wireless also, but these are exceptions, like in hilly areas or a coastal area where probably laying cables is a difficult thing. Then probably we can go for a wireless link between the tower and the mobile switching center as well. So what's for today's class, or what's in store? Well, today we are going to talk about some cellular radio principles. So what are these cellular radio principles? Okay. So what are these cellular radio principles? Well, when you understand the idea of cells, then there exist many new concepts which were not the case, or which were not required in case of a landline telephone. For example, we need something like, or rather, we realize something like frequency reuse. So, what is frequency reuse? In the earlier class, I was talking about this. We said that the frequency band is generally divided into several sub bands, and each band is dedicated to a particular user so that they can communicate with the tower. Now, as there are only a limited number of such bands available as regulated by a regulatory authority. For India, the regulatory authority is TRAI, TRAI, Telecom Regulatory Authority of India. In case of US, it is FCC, or Federal Communication Commission. And obviously, in every country, there is such a regulatory body. Now, such regulatory bodies have already specified some frequencies for this band. And there is a constant war between the telecom operators and these regulatory bodies. The constant war is something like the telecom operators like Vodafone, Jio, Airtel, and so on. They want more and more number of bands so that they can obviously provide more customers. On the other hand, the regulatory bodies are not willing to give a lot of spectrum, because they have already given those spectrums to various other bodies. For example, nobody have foreseen that such a huge amount of mobile subscribers will come into the picture. So when the bands were allocated, why this band allocation is important? Well, if you allocate the same band to all, then everybody will transmit in the same band, and nobody can understand anything, because everybody will be transmitting in the same band. So it's like you are giving a water pipe connection, and then if you are giving different pipes to different households, then it's fine. But if you just think that with one pipe everybody can take water from, obviously there will be quarrel. So that's what we want to avoid from the policy side. And those policymakers have already given large chunks of spectrum to the satellite and to the defense and many other applications. And now when the cellular operators like Reliance, Jio, and so on, or BSNL, they demand more bands, there is nothing left. So they have to rearrange, and for that they need permission from either from the defense sector or from the satellite sector, and they are not ready to give up their spectrum. So there is a continuous war, and that's why this spectrum auction is such a high value drama, which happens almost every few years. And whenever the FCC allocates some spectrum, it's a national news, even an international news. And even in TRAI also, like you have probably heard about all those kind of scams and so on. So there is a lot of money involved. In short, the frequency is a very scarce, or spectrum is a very scarce resource, and it is useful to reuse it again and again. So I'm coming back to our first point, which is written in this slide, that we are going to realize frequency reuse. Well, if you can make up smaller and smaller cells, then you can reuse the same set of frequencies again and again, and then you can probably accommodate more number of users. So that's what is in the heart of the cellular radio, and that's why the cellular radio has been flourishing for last 30 years by continuously shrinking their cell sizes and reusing the frequencies again and again. So that's probably the main fueling factor behind the growth of the cellular designers, or like how we can cope up, how we, the designers of cellular radios, can cope up with the demand. That's the secret. Now, the second, third, and fourth points, which is handover, power control, location update, paging, etc., these are not actually the advantage, or what I should say, the pros. Rather, these are the special things you need to realize when you have a cellular structure. So the first thing is a pro, but the second, third, fourth things are characteristics of cellular radio, but they are additional tasks that are imposed upon because we are going from a landline to cellular radio. Well, for example, let us start with handover. What we mean by handover? Well, if you are moving, then it is possible that you are moving out of a cell coverage area to another cell coverage area. That means you were serviced by some other tower few moments back, and now you have to get the service from another tower. So the network needs to know all about this, and the network needs to transfer the control of your phone from one tower to another tower. This process is generally called as handover. And handover means a lot of data exchange because, first of all, the network needs to know where, in which direction you are going. And then probably the network needs to notify those towers in advance that somebody is coming to you, so you should take care of that. So how this works is like, and it's actually related with the next one, which is called power control. So I will talk about power control a little bit, and then I come back to handover. Well, power control is something like, in landline phones, it was not the case, because in landline phone, you were always getting the fixed amount of power, or rather voltage. It gets attenuated with distance a little bit, but still it is good enough to power up your phone. But when you are in wireless domain, then if you are close to the tower, then you get a high signal, and if you are away from the tower, then you get a low signal. This is not a very good design. So what we do is we continuously monitor the power level which we are receiving from the tower, and we are asked to increase or decrease our mobile power according to that. So it's something like something like this goes on, that if you are closer to a tower, then the tower says that, okay, you are very close to me, you need not to transmit at such a high power level, you reduce your power. And when suppose I am going away from the tower tells my mobile that you are now going away, because your signal power is going down. It is continuously monitoring the signal power. And that's why whenever your phone is turned on, you think that nothing is going on, but actually there is a lot of communication going on between your phone and a tower, which probably you are unaware of. Such kind of, like, this is power control. So when you are going away from the tower continuously asks the mobile phone to reduce the power level. Well, with this power control, the tower also knows that whether there is a possibility of handover or not. Suppose you are continuously going away from the tower, that means your power levels are continuously decreasing. So when the tower sees that, okay, this person is continuously moving away, so it is very likely that this person will soon be out of my coverage area. So I should probably notify the network. So what the tower does, tower sends a signal to the mobile switching center, and mobile switching center identifies all the nearby towers and asks them, you start monitor this person. So they also start power control. Now one of the towers will feel that, okay, the power to that tower from my mobile is continuously increasing. So thereby the network identifies, okay, this person is leaving this cell and going towards that cell. So this person should be handed over from this tower to that tower. So this is how the power control goes on and handover goes on in cellular radio. Now, in order to help the cellular radio network, we also do some kind of location update. Like, the mobile itself also sometimes updates its location after a certain time, so that probably this action is helped. And then there is something called paging. Paging is searching. It's something like, whenever an incoming call comes, then you need to get identified under which tower you are currently in, and there you should, and there the call should be delivered. Well, this is fundamentally different from what we have in a landline telephone. In a landline telephone, once you dial a number, it is always made sure that the corresponding line is connected to your phone. So there is no such searching or paging kind of operation. Suppose you dial, for example, you dial 0343 275 4380. So whenever you are dialing 0343, the network knows, okay, I need to transfer the call to Durgapur. When you dial 275, the network knows, okay, I need to transfer it to the NIT Durgapur exchange. And then when you dial the last four digits, 4380, automatically the network identifies, okay, the line number 4380, which is connected to the exchange, the call should be transferred to that. So the mobile number itself, sorry, the phone number itself in landline telephone tells the network where to send the call. On the other hand, in case of mobiles, there is no such indication. When you are dialing, suppose 923134620, and it can be anywhere. It can be in Durgapur, it can be in Bhatinda, it can be in Kiev, and it can be anywhere. So you need to identify the mobile phone, the locality, and exactly which tower it is getting served. Now, that means the network needs to maintain some kind of database so that whenever a call is going to a mobile, then the network can properly identify the mobile and transfer the call. On the other hand, when you are making an outgoing call, such kind of searching is not required because you are simply asking the nearest tower to deliver your call. So more task or more database is involved when a call is coming to your mobile rather than when you are making an outgoing call. Obviously, if you are going to call another mobile, then obviously on the other hand, the same action goes on. But when you consider incoming and outgoing calls separately, then the more database kind of activity is involved in our incoming call rather than an outgoing call. Okay, so let us now talk about some kind of databases, which I explain in the next slide. Okay, so there are actually two type of databases in mobile network. Uh, the home location register and the visitor location register. Now, what are these home location register and visitor location registers are? Well, home location register is a total database of your mobile phone, like your IMEI number, your total subscriber information, and so on. And this database is generally maintained in a separate kind of database. It's like uh, every telecom operator has a cloud or big data center kind of thing. Not cloud, mostly data center. So they have a data center kind of thing, and these data centers are separate entities. Like they have big warehouses kind of thing where there are a lot of server which stores such kind of data. So they maintain a big database of all the customers, their plans, their IMI numbers, their phone, their call record, and everything. Now, this big database is generally not consulted for every incoming call, because if you need to fetch the data from this big database, then it will take a lot of time. So what we do is we do a two-stage hierarchy. Like there is a big database, and then there is a smaller subset of this database, which is called visitor location register, and that is stored in the mobile switching center. So it's something like if you are using an Airtel phone, then all of your subscriber data is somewhere near Noida or Gurgaon, where is the data center for Airtel. But there is a mobile switching center of Airtel in Calcutta. So your limited data set is stored in Calcutta, which is good enough to transfer your call to your mobile. So what is the VLR? And obviously HLR contains the current VLR. So what is the VLR? VLR is actually the database that is stored in the current MSC or exchange, and it contains the approximate location of my mobile. So at present, if I consider my network connection, I have a Airtel mobile. So my home location register is probably somewhere in Noida, where they have put, okay, this person is in plan 385, this person is using a Samsung mobile phone, his IMI number is this, and so on. So everything data record is in Gurgaon. Whereas I am currently residing in West Bengal, so that's why there is a mobile switching center in Calcutta, which stores a limited set of information. Okay, this person is in Durgapur, one area, and if a call is to be routed, then probably I should send the call to the Durgapur area. But obviously the visitor location register does not exactly know that I am currently in Bidhannagar, Durgapur, and my mobile tower is this Bidhannagar tower. So that it is not known. So how these two things works in tandem? Well, if somebody calls to my mobile, and if I am not moving away much, Then the visitor location register is actually the suppose somebody is calling from Maharashtra, and he types the number that it is 923134620. So obviously the network identifies that it's a Airtel number, and it consults the HLR, and the HLR says that okay, the current BLR is in Calcutta, so this person is in Calcutta. So simply the call is transferred from Maharashtra to Delhi to Calcutta. The HLR is not extracted fully. Now, when the a VLR is contacted in Calcutta, the VLR says that this person is somewhere in Durgapur. So the call comes to the Durgapur. And in Durgapur area, whatever Airtel infrastructure has, they now then start searching me. Like they search probably 10 towers which are in Durgapur, which with Airtel. They search all these 10 towers and they send a broadcast message. If you are 923134620, then please respond. And the those towers also send this information. Now this information comes to my mobile, and my mobile responds, okay, I am the person, I am currently in under Bidhannagar tower, so if you have an incoming call for me, I am ready to accept. So this is how the whole thing goes. So the scheme is a bit involved, but still rather simple when I am not roaming. But if I am roaming, then the whole thing becomes a bit more complex. In that case, the VLR gets shifted from Calcutta to somewhere else. Like suppose I have bought my SIM card in West Bengal, but now I am currently in Kerala. Now, when I am in Kerala, obviously again the person calls from Maharashtra. That call goes to Delhi. But now, this when the Delhi is going to contact Calcutta, Calcutta says that he is not under me. He has transferred to somewhere else. To avoid such kind of to and fro movement, what happens when I go to Kerala? When I switch on my mobile phone for the first time, I myself update my location. Like suppose I have taken a flight, and when I land on Kochi airport, whenever I turn on my mobile phone searches for the nearest towers and tell them that, see, I have a valid SIM, can you please connect? And thereby they know that okay, this person is originally having a Airtel number, and probably he is having a HLR like this. Now the HLR is getting contacted. The HLR says that okay, the VLR is in Calcutta, so now you are in Kerala, no problem. I am asking to shift the VLR from West Bengal to Kerala. So this is called location update. So even before a call can come to me, my VLR is transferred to Kerala. So next time when a person is calling me, the Delhi HLR redirects me to Kerala VLR, and then my call gets connected. However, sometimes this location update and update is not frequent, and probably the person may move very frequently, and in those cases, it takes a longer time to connect. So you will find that whenever a person is roaming, generally it takes a longer time to connect to that person. Very small difference, but still it is perceivable. Whereas whenever a person is in their home state, then talking to him or her is much easier. So that's what the databases are about, the home location register and visitor location registers. And then I would like to talk a little bit about the radio channels, and then we will finish this class. Okay, so these are the radio channels I want to talk about, and in the next class I will be talking about what happens in detail when there is an outgoing call, when there is an incoming call, what happens during a handover, and so on. Anyway, so what I want to talk about here is that when we consider radio channels means wireless channels. These channels are between the mobile phone and the tower. Well, it is very common for you to view that there is only one channel between the mobile phone and tower. Well, actually, there exists one physical wireless channel, but that is divided into many logical channels. That means some part of that wireless link is used for some purpose, some other part is used for some other purpose. Well, at least there are two different parts of that channel. One is the common control channel, the other one is the dedicated user channel, CCCH and DUCH. Well, DUCH is pretty straightforward to understand. DUCH is the part of the channel which is used for communicating, that is transferring your speech, getting data or something. So actual information that we want, or we want to send, or we want to receive, that goes to DUCH. So that is one part. However, apart from that major chunk which is DUCH, there is also a small part which takes information to and fro between your phone and the tower, which generally we don't see. Like I was talking about this location update, I was talking about this paging, I was talking about this power control, I was talking about handover. So all this information actually goes through this common control channel. So these are called signaling information. And there are two different type of signaling information. One is in uplink and one is in downlink. Uplink is when you look upward. That means from mobile to the tower. When you are looking from mobile to the tower, you are looking upwards. So that's why it is called uplink. And downlink is the tower is looking downwards to your mobile. So that's why it's called downlink. So in the downlink, what information passes through the common control channel are that there is paging information, then there is identification information, then there is location information, and then there is power control. Paging information is required when a new call is coming. Identification is required when the mobile is switched on for first time. The location information is about the location of the tower itself, and the power control because the tower needs to continuously monitor whether you are moving inside the cell or not. On the other hand, in the uplink direction, it's something like obviously location update is one of the component. Like if you are turning your mobile phone for the first time in Kochi airport, obviously the location update request goes from your mobile to the tower. That goes through the common control channel. And then there is also a call request that if you want to make a new call, that is outgoing call, that we also transfer through the common control channel. That means the number of digits that you type, like somebody is typing 92313, something like that. So that digits should go through a channel, which is called also common control channel. On the other hand, there are dedicated user channels, and these dedicated user channels are the channels which the user uses to communicate to the tower, through which the actual voice communication, the data communication goes. Now, dedicated user channel are something like one per user, and they are not like they are much lesser compared to the total number of subscribers. Like if you have say 500 customers in one cell area, there might be 10 or 20 such channels because not all the people are active all the time. So there are only limited number of channels available, and they are not by dedicated we do not mean that it is meant for a particular person. Dedicated means for the session only they are dedicated. So it's like you want to make a call, you are given a particular channel, and for that session it is dedicated to you. But once you hit the end button, then obviously it is not dedicated to you anymore, it is being transferred to somebody else. So that's the idea of the dedicated user channel and common control channel. But all these channels I was talking about is the BSMS link. So I'm going upward once again. So when I was talking about these channels, we are talking about this BSMS link or this wireless link I was talking about. This when I talked about the radio channels here. And apart from that, there is also a wired link between BS and MSC, which is between this tower and this mobile switching center. Now, these links can be of two types. Mostly it is wired and mostly it is made up of optical fiber. But sometimes, as I said, that in coastal areas or in hilly areas, you can also have another wireless link between a base station and a mobile switching center. And it can be microwave as well. So that's all from today's class, where we have discussed some basics of cellular radio. Let me recap what we discussed today. We have discussed about the basic structure of a cellular mobile radio, and then we have talked about the cellular radio principles, like what we mean by frequency reuse, what we mean by power control, what we mean by handover, what we mean by location update and paging. And then we have said that there are two types of databases involved in such mobile communication. One is HLR, the other one is VLR. And finally, we talked about the BSMS link, which is mostly wireless, and there are two logical divisions, CCCH and DUCH. And there can be also there is also a link between BS and MSC, which is wired, but sometimes it can be wireless as well. So that's what we had to offer into this class, and I'm stopping the recording now. If you have some queries, you can ask me now, or we will break the session.